Hi students, welcome back to our physics classes. Today we are going to start our new chapter, that is electromagnetic waves. So as I already told you, some topics from this chapter are removed in the revised syllabus, and here in this chapter only 2 or 3 topics are remaining. And another importance of this chapter is you have done your project on the topic electromagnetic waves. And while we are going through the new syllabus, that is revised syllabus, that topics only remaining in this chapter. That means already you have learned this chapter, you have already done your project work on this topic electromagnetic waves. Anyhow, we are going through the concept of electromagnetic waves once again. Okay, what is an electromagnetic wave? An electromagnetic wave is a wave in which an electric field and magnetic field are varying sinusoidally in mutually perpendicular directions. And moreover, these two fields are acting perpendicular to the direction of propagation of wave. Such kind of a wave is called electromagnetic wave. Which means, suppose you are having an electric field and magnetic field, and electric field is acting in y direction and the magnetic field is acting in the x direction. So perpendicular to both, if wave is traveling and this is the propagation direction, and which is perpendicular to both magnetic field and electric field, such a wave is called electromagnetic wave. So in this direction, c is the velocity of light and it is traveling with the velocity c perpendicular to both electric field and magnetic field. Remember, electric field and magnetic field are perpendicular, electric field and propagation is perpendicular, magnetic field and propagation is perpendicular, which means all these three are mutually perpendicular. All these three are mutually perpendicular. Clear? So that is an electromagnetic wave. So electromagnetic waves are, since from this it is very clear that light to propagate means electromagnetic wave propagates in a direction perpendicular to both electric field and magnetic field, which are varying sinusoidally. That means sinusoidal variations are there for this electric field and magnetic field. Both are varying according to a sine function. So sinusoidally these two fields are varying. That is the reason for generation of electromagnetic wave. So electromagnetic waves are moving in a direction perpendicular to the direction of its course, which are vibrating here. Electric field and magnetic fields are vibrating here. So such kind of a wave propagation is known as transverse wave propagation, which means electromagnetic waves are transverse in nature. That means they are transverse waves and they are moving perpendicular to both variation of electric field and magnetic field. Clear? So that is the basic idea of electromagnetic waves. And how such a varying electric field and magnetic field, both are perpendicular to each other, are generated. Suppose when you are having a charge, that charge can provide you an electric field. Suppose that charge is moving. So a moving charge can generate current, and that current can generate magnetism. So whenever you are having a moving charge, that moving charge can produce electric field as well as magnetic field. And such kind of moving charges are accelerated. That means their velocities are changing. So it can generate a varying magnetic field that can generate a varying electric field. So we can have a varying electric field and magnetic field associated with a moving charge. That means accelerated charge. All kinds of movements are not accelerated, but accelerated charges are there. Then they can produce crossed electromagnetic fields which are varying according to a sinusoidal function. So electromagnetic waves are generated from accelerated charges. Okay. So we can list out some common properties of electromagnetic waves. One property, the production itself, we can assign, that is they can be generated from accelerated charges. Electromagnetic waves are generated from accelerated charges. And the second one is no material medium is required for them to travel. No material medium is required for them to travel. And the third one is all these are moving with a constant velocity called c, that means 3 into 10 to the power 8 meter per second. Then the direction of variation of electric field and magnetic field is perpendicular to the direction of propagation, then electric field and magnetic field are varying simultaneously with respect to perpendicular directions. Then in free space, the magnitude of electric field and magnetic fields are related by E by B is equal to C. That is another relation, that is ratio of E and B, that is E by B is equal to C in vacuum, where C is the velocity of light in vacuum. And the energy of electromagnetic wave is divided on the average equally between electric and magnetic field. Energy of an electromagnetic wave is equally distributed along its magnetic field and electric field. So these are the energy density. One more point is that is energy density, and energy density in electric field E in vacuum is 1 by 2 sigma E square, and along the magnetic field it is 1 by 2 B square by mu 0. And the energy density, we have already said that energy is distributed equally along electric field and magnetic field, and it is 1 by 2 sigma, epsilon 0 E square in electric field, 1 by 2 B square by mu 0 in magnetic field. That are the energy densities, energy per unit area, unit volume, that is energy density, and it is distributed equally along electric field and magnetic field. So these are the common properties of this electromagnetic fields, electromagnetic waves. Okay, common properties of electromagnetic waves. And I already told you, when charges are accelerated, electric charges are accelerated, electromagnetic waves are generated. So we are getting different kinds of radiations from these kind of accelerated charges. And when we are listing out all these electromagnetic radiations in a particular order means either it is in the increasing order of frequency or decreasing order of frequency. And if you are arranging electromagnetic radiations in increasing order of frequency, then automatically that will come decreasing order in wavelength, because wavelength and frequency are inversely proportional. So if you are arranging the electromagnetic waves in the increasing order of increasing order of frequency, then that will be in decreasing order of wavelength. Or you are arranging electromagnetic waves in the decreasing order of frequency, then that will be increasing order of wavelength. Anyhow, generally we are arranging the electromagnetic waves in such a way, increasing order of frequency. That means if it is increasing order of frequency, decreasing order of wavelength. So electromagnetic spectrum means the arrangement of electromagnetic waves in a particular array. That means either in the increasing order of frequency or decreasing order of frequency. Anyhow, generally we are having electromagnetic waves as radio wave, microwave, infrared, then visible light, generally we are writing as light, then ultraviolet, then X-rays and gamma rays. So these are the major members in electromagnetic spectrum, starting from radio waves to gamma rays. And remember, it is in the increasing order of frequency. As we move from radio waves to gamma rays, its new frequency increases. Similarly, as you move from gamma rays to radio waves, its wavelength increases. Okay, that means frequency and wavelength are inversely proportional. Okay, now listen carefully. That means now we are going to describe each member in this electromagnetic spectrum. Each member in electromagnetic spectrum, their production, properties and uses. Okay, so we are starting with the increasing order of frequency. So the first one we are taking as long wave. So long wave, in some books you can find these amplitude modulated waves are there. Amplitude modulated waves. So amplitude modulated waves are also a part of this electromagnetic spectra that are known as long waves. So long waves are having the wavelength range 5 into 10 to the power 6 to 6 into 10 to the power 6 meter. Its wavelength range is 5 into 10 to the power 6 meter to 6 into 10 to the power 6 meter, and its frequency range is 50 hertz to 60 hertz. Its frequency is coming under 60 hertz to 50 hertz, and its production weak radiation from AC circuit. These are the weak radiations coming from an AC circuit. So that is long waves. Then coming our radio waves. So radio waves, its frequency range is 10 to the power 4 meter to 10 to the power minus 1 meter. 10 to the power minus 1 to 10 to the power 4 meter. Then its frequency range is 3 into 10 to the power 9 hertz to 3 into 10 to the power 4 hertz. 3 into 10 to the power 9 to 3 into 10 to the power 4 hertz is the frequency range. And electric circuit, radiation in oscillating electric circuits can produce radio waves, and they can be reflected and they can be diffracted. Reflection and diffraction are two properties shown by radio waves, and they are used in radio, TV communication systems, cellular phones use radio waves to transmit or voice communication in ultra high frequency UHF band, ultra high frequency band. So the radio and generally used in radios and televisions for communication. So that is radio waves. Then microwaves, that short waves or short radio waves or microwaves. Its wavelength range is 10 to the power minus 3 to 10 to the power minus 1 meter. 10 to the power minus 3 to 3 into 10 to the power minus 1 meter. Then its frequency range is 3 into 10 to the power 11 to 10 to the power 9 hertz. 3 into 10 to the power 11 to 10 to the power 9 hertz is the frequency range of microwaves. And their production by oscillating currents in a special vacuum tubes and by electromagnetic oscillators in electric circuits. These microwaves can be generated, and its properties, it can be reflected, it can be polarized. And in radar system used in aircraft navigation, then long distance wireless communication, microwave ovens, and all these instruments are based on these microwave properties. Microwave oven is common, and long distance wireless communication, then radar systems or microwaves are used. Okay, the next is infrared radiation. So generally heat radiations are infrared radiations. Its wavelength range is 8 into 10 to the power minus 7 to 5 into 10 to the power minus 3 meter. 8 into 10 to the power minus 7 to 5 into 10 to the power minus 3 meter. Then frequency range is 4 into 10 to the power 14 to 6 into 10 to the power 10 hertz. Frequency goes on increasing as you move from radio waves to as you go on from radio waves, the frequency range is going to increase. Then production from hot bodies, I already told you they are heat radiations. So from hot bodies and by rotational and vibrational transitions in molecules. Then their uses are properties, heating effect of thermopile and bolometer. Then reflection, refraction, diffraction, penetration through fog. All these are infrared radiation. Means infrared photoscope in photography. I hope you know that in foggy area or rainy days when photos are taken, instead of visible light, these infrared radiations are used. Then its uses are for providing electrical energy to satellites by means of solar cells, for producing dehydrated fruits, for treating muscular strain in solar water heaters and cookers, for weather forecasting through infrared photography. I already told you infrared photography. Then in greenhouse to keep the plants warm, and in warfare to look through haze, fog or mist. So that are infrared radiations. Okay. Then visible light. Next to memory is visible light. You know what is visible light, and it is 4 into 10 to the power minus 7 to 7 into 10 to the power minus 7 meter. 4 into 10 to the power minus 7 to 7 into 10 to the power minus 7 meter is the wavelength range, and 7 into 10 to the power 14 to 4 into 10 to the power 14 hertz is the frequency range, and radiated by excited atoms in gases and incandescent bodies. Then reflection, refraction, interference, diffraction, polarization, photoelectric effect, photographic action, and sensation of light. All these are the properties shown by visible light, and reveals the structure of molecules and arrangement of electrons in external shells of atoms. Visible light are used for. Then you know that visible light is used for the sensation of vision and all. That is visible light, that is very familiar to us, and we will learn about visible light in the coming section, that is optics. Again, ultraviolet radiation. You know ultraviolet radiations 6 into 10 to the power minus 10 to 4 into 10 to the power minus 7 meter is the wavelength range. Then 5 into 10 to the power 17 to 7 into 10 to the power 14 hertz is the frequency range. And they are produced in sun, arc, vacuum spark, and ionized gases are the major source of UV radiations, and all properties of gamma rays but less penetrating and produce photoelectric effect absorbed by atmospheric ozone harmful to human body. That are the properties of ultraviolet radiations. Then uses of ultraviolet: detection of invisible writing, forged documents, fingerprint and preserve footsteps, to destroy bacteria, and for sterilizing the surgical instruments in bulgar alarms and studying molecular structure. I hope all of you are having a KENT, that means a water purifier system, unit in your home. So on that, if it is a KENT, you can see at the and that water purifier it is in UV protection. What it means, UV protection? It is having a UV source inside, and UV radiations are passing through the water, and if any germs or bacteria is there in water, it can be killed. So UV radiations, UV protection means like that only. So that is UV radiation. Then comes X-rays. So UV radiations, then X-rays. X-rays, you know what is the use of X-ray, and the X-rays wavelength range is 10 to the power minus 13 to 10 to the power 3 into 10 to the power 8 meter. 10 to the power minus 13 to 8 into 10 to 3 into 10 to the power minus 8 meter. Then 10 into 3 into 10 to the power 21 to 10 to the power 16 hertz is the frequency range. Then how or why or when it is produced? By sudden deceleration of high-speed electrons at a high atomic number target, and also by electronic transitions among innermost orbits of atoms. That is the production of X-rays. Then properties, all properties of gamma rays, but penetrating power is less than the gamma rays. And uses in science for studying structure of inner atomic electron shells and crystals. X-ray are used for finding the inner structure of atomic model. Then in surgery, for detection of fractures, diseased organs, formation of bones and stones, observing the progress of healing bones, all these are X-rays are used. Suppose sometimes when we have any fracture or something, then first diagnosis is X-ray. Okay. Then in engineering, for detecting faults, cracks, flaws and holes in finished metal products. Then in radiotherapy, to untrackable skin diseases, in cancer-like diseases, X-rays are used. So X-rays are more used in our medical systems. Then the next one is gamma rays. The last one is gamma rays, and its wavelength range is 10 to the power minus 14 to 10 to the power minus 10 meter. Then frequency range is 3 into 10 to the power 22 to 10 to 3 into 10 to the power 18 hertz. See, its frequency is very high. Then production by transition of atomic nuclei and decay of certain elementary particles. And their properties: chemical reaction on photographic plates, fluorescence, ionization, diffraction, highly penetrating, chargeless, harmful to human body. And uses provides information about the structure of atomic nuclei. So these are the members in electromagnetic spectrum, and you should be aware about the uses of this electromagnetic spectrum, members and production, wavelength range. And if you know the wavelength range or frequency range, then the other is you can easily calculate, because nu is equal to V lambda. Nu is equal to V lambda. So nu is the frequency, V is the velocity, and lambda is the wavelength. You know velocity of electromagnetic waves is same, that is 3 into 10 to the power 8 meter per second. So if you are knowing lambda, then automatically you can calculate nu. If you are knowing nu, you can automatically calculate the value of lambda. So remember, any wavelength or frequency of electromagnetic waves, then the other is easily calculated. And we have seen, when these separately we have seen the electromagnetic members, so they are having their own properties plus that common properties that we have already assigned for all the electromagnetic waves. So that is a simple chapter. Only this much is there in that chapter. You read and you learn, and nothing extra derivation or explanation is not required. So go through and by heart these properties and the wavelength range and all. Okay, that's all for today, and we will meet in the next class.